which is the old physics theory, okay, which was developed first before the next topic on the waves, all right, on the waves and also on the radiation, okay, and electromagnetism, which was found later, all right. So this is, this is done after, because the first part is actually is about the mechanics, all right. So it involved with the physical, all right, with the physical mechanisms, all right. Let's say, for example, you are going to know about the speed, all right, the acceleration, okay, and then the moment of inertia, all right. So that's all what we're going to be studied, all right, in the physics one, all right. So the physics one is about the mechanics, okay, and then in the later part, after the electricity, okay, after the electricity was found, so that's why we have another study of physics. So it's involved the electricity, right, and magnetism, all right. And later on, so with the advancement of the physics study, so we have a theory on the nuclear physics, all right. So about the data and so on, okay. So that's how actually the the physics study evolve, all right, from time to time, okay. But it doesn't matter, although you already learned about the electromagnetism and also the wave, all right, in the physics 2. And then now you are going back, actually you're going back to the first part of the physics, all right, first part of the physics study. So which you should learn more on the mechanics. Okay, so basically, so the physics that you are going to study in this course is almost similar to what already you did study during your matriculation or STPM course. Okay, but it might be a little bit deeper than that. Okay. Um, all right. So before I start with our first topic of the course, I'm going to give you some introduction about the course. Okay. Let me share my screen. Okay, you guys can see what I'm presenting now.
Yes, Doctor.
Yes.
All right. So let me introduce myself. Okay. So you can call me Dr. Amir. All right. So I'm actually a graduate engineer. All right. Certified by Board of Engineers Malaysia. All right. So actually, my background, actually, I am not a physicist. I was an engineer. All right. I've been an engineer. So I did my study in Purdue University in the United States. Okay. So my field was electrical engineering. Okay. And then later I did my Master of Science in the Sensor and Instrumentation in the UPM. If I'm not mistaken, I did my study during 2011 to 2012. Okay. And then further in 2012, I further my study to the PhD level. in the electronic engineering, okay, in the specifically in the wireless communication area. Okay, so the wireless communication involves the, of course, if we relate to physics, it's involved the electromagnetism and waves theory. Okay, so for that I did my study partly in Sheffield, UK, and also in UPM as well. And then my expertise is in the MATLAB. So MATLAB is computation in the is the computational software. If you ever heard about that, so it's actually involve a lot of, if you are trying to solve the equations and so on, right? So you can use MATLAB to do that. So in the MATLAB also there are many useful tools that actually you can use to solve some of the physics problem. Okay, and what I'm what my expertise is in terms of algorithms, especially if you heard about the machine learning, all right, machine learning, the artificial intelligence. So that's actually my area. Okay, so you can go to my profile page if you are interested to see what I'm actually doing. All right, so you can go there. Okay, and then basically, if available later, you can visit me at my room in 213. So in the Physics A building. All right. So any concern, you can email me and also text me. All right. Or you can, but usually the students never call me, so I don't know. So probably that's a preferable method. You can contact me. So either by email or mobile. All right. So general info about the course. So we are meeting today. So weekly on Monday and Thursday. Okay, so we have 2 hours, 2 hour session today, and then also another 1 hour on Thursday, and the lab session will be tomorrow. Okay, so will be tomorrow at 8, also at 8 a.m. So to 11 a.m. So actually, this is my first class that I had. All right, this is my first class I had as early as 8 a.m. Okay, before this, I have never got a class at 8 a.m. So mostly, usually it starts at the earliest a.m. All right. So I hope everyone will enjoy the course. All right. So you can ask me any question that you like. All right. So at any time during my lecture or even after the lecture. All right. So it's not a problem. Okay. So all right. So hopefully we will can get done with our first lab tomorrow. Okay. So the first lab. So it will online. All right. So there will be no physical session. All right. So okay. So that's the time for the course. All right. So it is compulsory. It's compulsory for all of you to attend all lectures and the lab session. All right. So I'm giving you the course synopsis. All right. So as I said in the physics one, it involves about the mechanics. So the mechanics is defined by, of course, the motion of the system of, okay, so you have particles. Let's say you have um, in the particle, what you know is, of course, the atom. All right, the atom. All right, so it involves the movement of the atoms or the particles inside the atoms. So which we have the neutron, all right, electrons, and so on. All right. And recently, in the study of the particle physics, so you will have more smaller particles inside the atom. So it's not just neurons. Okay, it's not just a neuron, or it's not just a proton, so on. So the recent study, you also have the particle called neutrinos. Okay, so neutrinos is actually having about a zero mass. So if you are interested with that, so you can explore further. All right. And other than that, we're going to study about the rigid bodies. Okay. Multiple dimensions. So you have 1D, 2D, and also 3D. Okay. Which we will use the concept of uh, Newtonian mechanics. Okay. And then we will also discuss on the dynamics of the oscillating particles and the rigid bodies. And lastly, about the law of the thermodynamics and the applications in the thermal physics. Okay, so for the learning outcome, so if you can achieve all of this, all right, so you will get A grade for the course. Okay, of course, this is what is assessed. Okay, what is assessed from you. Okay, so you should be able to apply the physics knowledge in solving the problem related to mechanics, uh, on the vibration of the atom, all right, and the thermodynamics. Okay, and the second one, the student will also need to explain, all right, so explain or discuss about the physics principle that is related to mechanics, all right, waves and the heat. Okay, so this is P4 is related to the your psychomotor skill. So this is actually is tested, all right. This is actually is tested during the lab session. Okay, C3 is related to your knowledge, all right. And A3, which is related to the soft skill, okay, the number 3. So it involves about the solving a problem, okay, that is related to the concept of mechanics, all right, waves and also the heat systematically. Okay, so this is what will be assessed. Okay, so it's actually six. Okay, so this is actually what you're going to learn for the whole semester in this course. Okay, so I won't go one by one. So basically, you can later read about this. So I'm going to share this letter, okay, in the Ultra Blast. Okay, so all right. So that's the topic will be discussed. And then this is the textbook that I'm going to use in this course. Okay, so find a copy of this. All right. So it's basically a university physics by Young and Friedman. Okay. So that's the author's name. Okay. So, all right. This is important. Okay. So this is how the marks will be distributed, okay, for this course. Okay. So for the tutorial assignment, okay, so you have tutorial assignment so for every topic, okay, and then that's contribute to 10% of the mark, okay, and then you're gonna have a presentation later, so maybe at the end of the course that's contribute to 5% of the mark, and then for test 1 and test 2, so every of that contributes to 15 for the test, for the both tests, so it's consists of 30 marks. And then for the lab session, okay, for the lab session, um, uh, it is given 50 marks, okay. So for the psychomotor, you are assessed for 10%, and for the soft skill, which is the I think TS is the team skill, if I'm not mistaken. Later I will update you. So it will contribute to 5% of the lab marks. Okay. And then as usual, the final will be 40% of the total marks. Okay. So overall, sum up all of this, you will obtain 100%. Okay. Any questions so far? All right. So happy learning. So I expect everyone should get good grade in this course. Any question? All right. No question so far?
No question, doctor.
Okay, good. Okay, so we're going to start with our first topic. Right, so before that, give me 1 minute to open up my lecture slide. So actually it is similar that what I already shared you, all right, yesterday on the WhatsApp group. So for those who haven't get that copy, so probably for those of you who just joined, all right, who just joined, and then maybe I can forward it again. Give me 1 minute. Give me a couple of minutes. Okay. Okay, I already shared that. Okay, give me 1 minute to check my slide. Okay, can you see my screen now?
Yes.
Yeah.
All right, so we're going to familiarize ourselves with the units, physical quantities, and vectors. So I think it won't be a big deal for you because actually, because you learn the physics 2 first, which actually the more advanced part of the physics study. All right. So this one actually just like a revision for you. Okay. So this chapter, what you will learn is about the 4 steps that you can use to solve any physics problem. Okay. So about the fundamental quantities, right? And then how to work with units. Okay. And then we will discuss also about the vectors. Okay. All right. So this, okay, the nature of physics. So what is physics? So physics is an experimental science in which the physicists seek patterns that relate the phenomena of nature. All right. So need to always remember that physics is not a theory. Okay. Physics is not just a theory. So it is an experiment. Okay. So whenever you have the theory, so theory is the equation. So let's say you develop some equation, but you need to prove that. Okay, you need to prove that. So that involved with the experiments. Okay. So for example, you look at the right. You look at the right picture. So everyone know what is that? Have you been there before? Anyone of you have been there before?
No,
No. So have you seen this picture before?
I think so.
Think so. You know what is it?
Yes, I think so.
You think so? Okay. So it's actually as a leaning tower of Pisa. So it is located in the Italy. So at the city of Pisa. And then actually I have been there last 2 years. All right. So luckily during that time, actually it was just before the outbreak of COVID-19. Okay. So actually, Italy was the worst country in Europe that was affected with the COVID-19. Okay, and then luckily I was there, and I mean during that time the COVID-19 hasn't been outbreak yet. Okay, so if not, I was stuck there and then come back to Malaysia. Uh, because actually I went there for a conference. Okay, never mind. So the Leaning Tower of Pisa is actually one of the 7 wonders of the world. Okay, because it is the unique structure of the tower that is lean a little bit. So it's a lean a little bit. Okay, but it does not collapse until today. So it was developed. This tower was developed actually at that time. It is vertically up, so without any lean on that tower. All right. So, but due to some uh, problem with the soil structure, so over the years it leaned a little bit by a little bit. Okay, but it's still there. All right, it's still there because the engineer uh, that fits that I mean that problem, okay, manage to ensure that this tower still stands still until today. Okay, so that's why this tower is considered as one of the 7 wonders in the world. Okay, never mind. I just want to, because actually there is a more story about this tower. So actually the Galileo, all right, if you ever heard the name of Galileo Galilei, all right, Galileo Galilei is one of the physicists in during that time in the early 19th, all right, early 19th century, okay, early 19th century. So what he did that he tried to make an experiment, okay, tried to make an experiment by dropping, okay, by dropping objects, all right, by dropping objects from the top of the tower, okay, to study about the, as you know about the physics, is about the gravity, all right, is about the gravity. So what he learned that when he dropped the object that have different masses, it reached at the same time at the ground, meaning that it is not affected by the weight, okay, by the mass of the object, okay, when the free fall involves, okay. So that's about the free fall, okay. Why he did that study? Because before that, another physicist, I bet you already heard his name, Aristotle, all right. Aristotle mentioned that um, when the object is dropped from a height, okay, it will travel, okay, at different speed, all right. It will travel at different speed, okay, or it will accelerate at different speed. So of course, when different masses, different object with different masses is travel at different speed or different acceleration, of course, the object that have bigger mass will reach the ground first. Okay, it will reach the ground first. But the Galileo proved that when the free fall involved, the mass doesn't matter. Okay, so that is what Galileo studied. So that is related to what we study in the free fall, where the mass is not related to the free fall of the object. If you want to try yourself, you can even try to take different, okay, different set of coins. Let's say you have 50 cents and also you have 20 cents. You can try drop it and then see by yourself. It will drop at the same time. Okay, it will drop at the same time. Okay, let me. Okay, I have 50 cents with me and also 20 cents with me. Let's see. Okay, even, all right, even that, you can try to drop you can even try to drop 50 cents and 10 cents to prove that the mass does not affect. Okay, the mass does not affect the time of the object drops from a certain height. Okay. So now let's say I have 50 cents and 10 cents. I drop it. And then you can see, you notice that the sound will be similar, because if one of this coin drop first, you will hear two drop sound. All right. If you just hear one, that means the time of the coins reaching the ground, okay, will be at the same time. Okay, let's see. Okay, so you only hear one drop sound. So that proves the Galileo finding was correct. Okay. Okay, let's continue with the lecture. Okay, you can see my slide now.
Yes.
Okay. So all right. So back to the what I'm explained. All right. So the physics is an experiment. All right, it's an experiment, and then in the statement, it also said that the physicists seek patterns. All right. So these patterns are the theories. Okay. So a very well established or widely used theory is called a physics law or principle. Okay. If the theories are, of course, everyone agree with that. So everyone agree with that. So it is called a law or a principle. Okay. So in the solving problem in physics, so all of the problem solving strategies and examples in this book. So we will follow the 4 steps. Okay, first we will need to identify. All right. So identify related with, we need to find out what is the relevant concept, the target variables, and the known quantities. Okay, as stated or implied in the problem. And then we need to set up the problem. So we need to use, okay, choose the equation that we will use to solve the problem. Okay, and then once you identify, so what's the concept related, the variable, you set up the problem. Okay, once you set up the problem, and then you need to execute. Okay, execute means you need to find out the solution. Okay, so this is where you do the solution. So where you do the math. Okay, basically you have the equation. Okay, you identify what is relation, what is the equation related to this problem. Okay, okay, and then try to relate this equation with the problem, and then execute the solution, and then evaluate your answer, right? Whether your answer is correct or not. Okay, so to simplify the analysis, okay, so for example, we have the idealized models here. So we try to simplify the analysis of a baseball in flight. Okay, so we use an idealized model. Okay, so a real baseball in flight, of course, all right, of course, when we throw a ball, so during the movement of the ball from one side to another, okay, let's say you are throwing the ball to your friend. Okay, during the time of flight, of the ball, of course the ball will spin. All right, the ball will spin, it won't be static. Right, it won't be static. So because it will involve, okay, it will involve with the resistance of the air. All right, and also the wind that exert the force on the ball. Okay, and What else involved? Okay, so of course it has the vector on the direction of the, okay, and then so we have also the gravitational force on the ball, which depends on the altitude of the ball. Means that the height of the ball from the ground. Okay, we need to simplify that. Okay, so this is called as the idealized mobile, right? So we need to treat the baseball as a point object. So it's like a particle. Okay, so it's like a dot. Okay, so the ball, we treat that like a dot. Okay, so we neglect. So we neglect the air resistance. Okay, and the gravitational force on the ball is constant. Okay, so meaning that it doesn't depends on the altitude. Okay, so you have G, right? So you have G, so which is 9.8. Okay, so 9.8 meter per second. All right, so that's actually you want to simplify. All right, so when you treat the baseball as a point object, so you won't consider the ball spinning motion during the time of flight. Okay, so what you have here, you have the fixed gravitational force and also the direction of the motion of the ball. Okay, so that's the idealized model. So standards and units. So the length, time, and mass are the three fundamental quantities of physics. Okay, so we use the international systems, all right, which is, you always refer that as I. So SI, okay, is in terms of the French, all right. So which is a system international, all right. So system international, okay. So that stands for SI, okay. Or English definition is the international system. So it's the most widely used system of unit. In the SI unit, the length is measured in meters, okay, time in seconds, and mass in kilograms. Okay, but in certain countries, they are not using the SI units. For example, in the United States. So, for example, in the United States, they are usually use the old measurement system, okay, which is not the international system. Such as meters, they use yard. Okay, they use yard. Okay, and then for the mass, they use pound, pound and ounce. Okay, so that's for the certain countries. So, but in physics, so we use the SI unit. Okay, so everyone will be similar. Okay, so what we study in physics, so will be similar in Malaysia or in other countries. Okay, so the prefix, all right, the prefix. So what is the prefix? So we have the prefix used to create larger and smaller units for the fundamental quantities. Okay, so let's say one micro, okay, which is equals to 10 to the minus 6 meter. So that's the size of some bacteria and living cells. Okay, so you can also have, okay, let's say 1 gram. Okay, 1 gram. Okay, so you will have, so because you need to define that in terms of the physics unit. Okay, so for the mass, we use kilogram. So should be converted to the 10 of minus 3. Okay, and so on. Okay, and then an equation, okay, so must be dimensionally consistent. Okay, so terms to be added or equated must always have the same unit. Okay, so make sure that you are adding apples to apples. Hello?
Yes, yes, doctor.
Oh, okay. Actually, I didn't notice that I was during all the time. Where did my last explanation?
Page 8. Equation, page 8.
Okay, is this the one?
Yes, yes, this one.
Okay, so
I mean the previous one.
I haven't explained for this one.
Unit consistency and conversion.
Okay, so I already mentioned about the 3 minutes conversion to seconds, right?
Yes.
Okay. All right. So okay, repeat again about what I just explained. That I was talking alone. All right. So we are measuring the uncertainty. All right, of the measured quantity. So it is indicated by the number of the significant figures. So if we're going to be uncertain about something, all right, so usually on the number itself, so we put, let's say, 1.001. So we have the three significant figures. Okay, and then plus minus. Okay, plus minus, for example, 0.005. So mean that the uncertainty will be, okay, we can add 5 more than you can add 0.005 to the number, all right, or you can minus up to 0.005 to that numbers. Okay, so meaning that the significant figures of that uncertainty cannot be smaller than that. Okay, so if you have, okay, again, okay, I give a different example. For example, 1.01. So plus minus cannot be more than 0.01. Okay, it's smaller than that. Meaning that you cannot have at 0.009 or 0.006 or 0.2. So you cannot have that. Okay, because it is not possible to do that. So for the uncertainty, so it must follow the significant figures of the mean range, all right, of the mean range. Okay, for example, you have 0.03. Okay, so you cannot have the significant figures of less than 0.01. Okay, so you guys are clear with that? Okay, all right. Also for multiplication and division, okay, so the answer cannot have more significant figures than the smallest number of the significant figures in the factors. Okay, mean that if you multiply 1.01 plus minus 0.02. Okay, and then you have another number at 1.1 plus minus 0.2. Okay, so the answer can be, let's say, it can be 2.12. Okay, 2.12 plus minus 0.02. That should be fine, but it cannot be smaller than that. Okay, plus minus 0.002. Okay, so that's about the uncertainty, okay, and the significant figures. Okay, you look at the picture there. So you have the train. Okay, So involves in accident, okay, due to the driver pull up the brake is a little bit late, okay. Then when he should pull up the brake, let's say the time is actually 0.5 seconds late, okay, that cause actually the big consequences to his mistake, okay. The accident was fine if the train just out of the track. So now it's a very big damage, okay, because the train actually got pulled out of the building, of the terminal building of the station, and then so the building and the trains both got damaged. Okay, so it's a massive damage when even you got a very small error. Okay, so a small percent of error can contribute to a consequence. Okay, so let's see this video tutor solution. So can you see my screen on the web page? Can you guys see?
No.
No. Okay, let me. Sharing you on the screen. Can you see now?
Yes, doctor.
Yes.
Okay, just pay attention to all right what is explained there and how to solve the problem. Okay.
Um, I think there's no audio, doctor.
Pardon?
I mean, I think there's no audio. We can't hear any sound.
Hold on.
Okay.
Can you hear the sound?
No, doctor.
I think you have to re-present by
How do I do that?
okay, maybe you can stop share first. Then
Okay.
okay.
Okay, I stop sharing.
Okay, then when you press the present now button, right, then there is a column written there, a tab best for video and animation. Maybe you can try that.
Oh, okay, okay.
Yes.
Right there. For that.
Example 1.3, we're going to calculate the energy of an electron using Einstein's famous equation E. Example 1.3, we're going to calculate the energy of an electron using Einstein's famous equation E equals mc squared, where m is the mass of the electron and c is a universal constant of nature, which is the speed of light in vacuum. We want to find E, considering that we only know the mass to three significant figures, which is 9.11 times 10 to the minus 31 kilograms. The speed of light, however, is known to many significant figures, as shown here. However, E can only be to three significant figures since the mass is only known to that degree of accuracy. So here's the actual calculation. We have to square the speed of light. And notice that the 10 to the 8 is going to be squared. And when I do that, it's going to be, actually this exponent is going to become 16 and it has to be added to the minus 31. And I end up with 8.187 times 10 to the minus 14 kilograms meters squared per second squared. But that's in fact the unit of joule. So this is 8.19 times 10 to the minus 14 joules, where I have truncated my answer to three significant figures because, again, the mass is only to three significant figures. Though this seems to be a very tiny energy, roughly 10 to the minus 13 joules, the actual energy that an electron loses and gains in a chemical reaction is closer to 10 to the minus 19 joules. So this energy of the electron is much, much greater than typical chemical energies. And this ends example 1.3.
Okay, so you can see that video.
Yes.
Yes.
Cool, you heard the sound, right?
Yes.
Okay, so all right, so you saw that. Okay, you saw that. Let me share that. Okay, let me share that again. Okay, so you notice here that the given, all right, the given variables, all right, m. So you have the three significant figures. You have three significant figures, all right, and then okay, you look at the final answer. So the final answer cannot be more than that three significant figures, even though you have the units of C, right? So you have how many significant figures there? So you have 9 significant figures. So you cannot put that 9 significant figures, right? So you need to put 3 significant figures, which is the one that is given in the problem. Okay. All right. So that's how you should use the significant figures in the multiplication, right? Okay. So let's continue with the slide. So we're going to enter the vectors and scalar, right? So a scalar quantity can be described by a single number. Okay. So meaning that a scalar, so it is a number. For example, speed. Okay. A speed given, okay, a speed given as 10 meter per second. All right. So it is just a number. So it is a scalar quantity. A vector quantity has both a magnitude and a direction in space. Okay. For example, you are describing a motion of the ball. So it travels, okay, to the right, okay, to the right, or from A to B, okay, at a speed of, for example, 12 meter per second. So that's a vector because it involves the magnitude and also the direction. So in this book, okay, the vector quantity is represented in the bold face attribute type with an arrow. Okay, so it's a bold and you have an arrow on top of that. Okay, so that is a vector. Okay, so magnitude of that vector is written as A. Okay, so A without the bold, or you have the modulus, all right, A. So that's also of the vector A. So drawing a vector, so you have should be an arrow head. All right, so you should have an arrowhead. So where that is directed to. So the length of the line shows the vector's magnitude. Okay, so let's say you are drawing. Okay, you are drawing that on the paper. So let's say for one, so you're drawing that for the length of that arrow is cm. Okay, so that 3 cm is the magnitude of that vector. Okay, so you can give the scale for that. Okay, so you can give the scale. Let's say 1 cm is considered as, let's say, 9 units. So for 3 cm, so it is 27 units of that vector. And then the arrow, so the arrow, so we have the arrowhead at the destination. So the direction of the line, so the pointing out of the arrowhead is showing the direction of that vector. Okay, you look at the picture there. Okay, you have P1 to P2, and then you have P3 to P4. So the magnitude for P1 to P2 and P3 to P4 are similar. Okay, so you have one is vector A and another one is vector A z. So vector A z is also equals to vector A because the magnitude and the direction are similar. Okay, but you have another vector which is from P5 to P6. This one we have the similar magnitude, right? Similar magnitude, but different direction. So the direction is reverse. So we call that, for example, we call this as a vector B, but it is equals to the minus vector A. Okay, because it is the opposite direction of the original vector A. Okay, so I think so you could understand that. So any questions so far? All right, so no question. I mean, you have any question?
No.
Okay. All right, so we continue with how to add the two vectors. All right. So graphically, okay, so if we have two vectors, for example, A to B, so we have, so the one with the arrowhead is the head of the vector. All right, the head of the vector, and the one without the arrowhead, the flat one, is the tail. Okay, so we need to add the head with the tail, right? So for example, there we have vector A and vector B. Okay, so we add that both of them, we get the sum of that vector. So we call that, for example, we call that as a vector C. Okay, so you need to draw the tail. So at the tail of the vector A and the head, okay, at the head of the vector B. Okay, so that's how you get the vector C. All right. Okay. If you even add that, okay, let's say you put the B first. Okay. So you start with the B first, right? And then you add the A. Okay, it is similar concept. So you need to add the head to the tail. All right. So you start with the tail, right, at the vector B, and then meeting the tail, okay, meeting the, okay, the head of vector B meeting the tail of the vector A, okay. So the vector C is drawn from, you draw that from the T up to the head of the vector A, okay. All right, so that's it. Okay, so that's it for the vector addition. Okay, you can also, so that's the two ways. Okay, there's another way. So you can also add, okay, tail with tail. Okay, so the tail of vector A and then combine with the tail of vector B. Okay, but here is like a parallelogram. Okay, so you have the, so you need to know how to know the, to stop with the head of the vector C. All right, so you need to draw the parallelogram. Okay, so at the adjacent of that parallelogram, okay, in that, at the cubic of that parallelogram, so that's the head of the vector C as in the picture. Okay, and then you start that drawing from the tail of both vector A and B, okay, for that vector C. So there are three ways to add the vectors. Okay, this is by the graphic means. All right, so this is how graphically you can add the vectors, the two vectors. Yes, so this is for the concept of only two vectors. So you can have multiple vectors, not just two vectors. Maybe you can have 3, 4, 5, and maybe up to 10, or maybe more than that. Okay. So for that, so it will be more complex. All right. So, but usually we don't solve that using the graphical method. Okay. So, but here you need to remember. So there are three ways to add the vectors. Okay. So you have by adding A and then B, or B to A, or even you use the tail of A and tail of B and then draw the parallelogram, okay, and then you can project that vector, okay, so draw that. So that's the three methods. Okay, one more. So you have, when let's say when A and B are parallel, okay, so the magnitude are just sum of that. Okay, so the magnitude are just sum of that. But when A and B are anti-parallel, so meaning that A goes from left to right, B goes from right to left. Okay, so vector C will be A minus B. Okay, so A minus B, so it will be C is part of the vector A. Okay, so C is part of vector A, and then C plus B will be A, right? So I think this should be simple, right? Okay. Now, as just I said, so we already finished with adding two vectors. Now we are considering more than two vectors. okay, by the graphic methods. So a little bit complex, okay. But for 3 vectors, it's not so much complex. But if it is more, then it will be more complex. Okay, you can add several vectors by using the head to tail method. So the vectors can be added in any order. Okay, first, you find the sum of these 3 vectors. Okay, for example, okay, so you have vector A, B, and C. All right, so you place that, okay, from A, so you add head to tail, okay, from A and then B, so drag that tail of B, okay, and then you have head of B and then meeting tail of C. Okay. So first you add A and B. Okay, so A and B, you are going to draw a new vector. Okay, so you draw a new vector, let's say a vector D. Okay, so you have vector D, and then from the head of vector D meeting the tail of vector C. Okay, and then you can draw the result of vector R, okay, from the tail of vector D to the head of vector C. So that's the results for adding the vector of A, B, and C. Okay, you can add directly. Okay, add directly. So without having the vector D, so you have vector A from head to tail, and then head to tail of vector B, and then head to tail of vector C. So you add 3 of that, so you get the vector R. Okay, that's the second method. Okay, the third method. Okay, the third method. So you can, let's say, you start with vector V first, and then you add with the vector A. Okay, or you can even add after B, you can add C. Okay, add C and then later add A. It's not a problem. Okay, so from B to A and then A to C, so you get the vector R. Okay, so that's the 3 methods to add more than 2 vectors graphically. So to subtract a vector, okay, you can use the operation, okay, summation or subtraction. Okay, you add or minus. So if you want to subtract vector B from A, so A minus B, but B in its normal direction. Okay, so you just use the operator here to minus, so you got that. But if you want to use the summation or addition, so you need to use a reverse of the direction of the vector B. Okay, so you add vector A with the vector minus B. Okay, so you also get the same answer. Okay, so for example, with A and minus B head to tail, okay, you get the resulting vector. Okay, it is similar to A minus B. Okay, so A minus B, so you use that, okay, head to head. All right, so that's how you can subtract the vector. All right, so you can also multiply a vector by a scalar. All right, if a C is a scalar and the product of C A, which is A is a vector, has magnitude of C. All right, C modulus C, okay, absolute value of C A, okay, And then the figure illustrates multiplication of vector by a positive scalar and a negative scalar. Alright, for example, we look at A. So let's say we multiply a vector by a positive scalar, changes the magnitude. So magnitude is related to the length of the vector. Okay, you look there. So in the picture, you have A, and if we have 2A, so it is double of that A, alright? So because the magnitude change. So what change is the length of that vector. So that is when you multiply that a vector. But if you multiply that with a negative scalar, okay, negative means that the direction of the vector change. Okay, so it is in the reverse direction, and if the magnitude is bigger than 1, meaning that the multiplication involve the change of the magnitude as well. Okay, for example, there you have vector A, and then the magnitude is not 1, it's 3, and then the vector is negative. Alright, vector is negative, meaning that it is reverse of the direction of A, but multiplied by 3. So it's 3 times of that. So you change the head, the initial head of that vector A is on the right. So now the head is on the left. Okay. And then the tail, so changes respectively. Okay. From the left to the right. Okay. So that's how you do multiplication. Okay, multiplication by scalar of a vector. Okay, so how to add the two vectors at right angles? So to add the two vectors that are at right angles, first add the vectors graphically. Then use trigonometry to find the magnitude and the direction of sum. Okay. In the figure, right, so we have, for example, across countries here, and it's up 2.24 kilometers from her starting point. Okay, in a direction of 63.4 degrees east of north. Okay, so let's say you want to define the vector at the right angle. So for example, okay, you look at the picture here. So you have, so over here is the starting point of the skier. All right, so it ends up to this location. Okay, but you want to define the two vectors at the right angle. So let's say this one vector and then this is another one. So you need to add up these two vectors, so you obtain the final vectors here. All right, so let's say you only have this final vector, but you do have these two. Okay, but you are assuming that you want to know what is the vectors to the north and then what is the vectors to the east. Okay, so you need to draw the straight line. All right, the straight line up to the north for one vector, and then up to the point where you can make the angle of 90 degrees to the next vector, starting from the tail to the head. Okay, so that's how you can add the two vectors at the right angle. Okay, so we are considering the components of a vector. So adding vectors graphically provides limited accuracy. So vectors components provides a general method for adding vectors. So any vectors can be represented by a component, the x component, ax, and the y component, ay. Okay, so let's say we have a vector here, a vector a. Okay, so because we are using the Cartesian coordinate, all right, so we have x, y, and even we can have z. Okay, if you are learning further later, especially in the electromagnetism force. Okay, but here we are simplified to the 2D Cartesian or rectangular coordinates. So we have x and y. So this vector A can be divided. Okay, you can separate that to two components in the x direction and also y direction. Okay, so to the y direction, okay, so we can define that that component as ay, and then to the x is sax. Okay, so what is ax? So ax is the magnitude of a, this vector a, cosine theta. So theta is the angle is made between the main vector a and the x component of that. Okay, and also to the y direction, so we have the component of ay, which is equal to magnitude of vector a, and sine theta. All right, so that's the definition of component. So whenever you need to find the component, so you need to find ay and ax. Okay, so that's the definition of components of the vector. So you can have positive and negative component of the vectors as well. So the component of vector may be positive or a negative numbers. Okay, so it depends on how the vectors is drawn, okay, on the Cartesian coordinate. For example, we have vector v. So vector v is in the positive of vector y, but it is in the negative of the vector x. On the negative of y, on the positive of y axis, but in the negative of x axis. So it has the negative bx component, and then it has the positive by component. And then another example, we have the vector c. Vector c is going to the negative of the y-axis, okay, negative of the y-axis, and also to the negative of the x-axis. And then we can have another one, okay, which is on the positive of x-axis and also the negative of y-axis. So it can be in any part of the axis, and then you just need to define that based on the direction of that vector. Okay, so we can calculate the components of a vector from its magnitude and the direction. Okay, so over here, let's say we have the angle alpha is measured in the wrong sense from the positive x-axis. So we must use the negative alpha. Okay, actually the alpha, okay, we should measure that actually from the 0 degree, okay, from the 0 degree up to here, okay, from the 0 degree up to here, meaning that it should be more than 270 degrees. Let's say, for example, here is 290 degrees. but the alpha, all right, maybe is 70 degrees. Okay, it is 70 degrees. So it is in the minus of that. So it should be minus 70 degrees because it is not on the counterclockwise direction when we are considering the angle. Okay. Also, we have another one. Okay, we have another one component. So we are defined, let's say here, actually E, vector E is in the negative y-axis. So it should be simple, but if you want to mention that, we have the component in terms of EX and also EY. Okay, EX and also EY. Then EX, okay, is measured, right? So it's measured, okay. So we have, we have here theta. Theta is measured from the EX, okay, up to the vector of E, and then we have the EY component, which is a beta, okay. So beta is from the positive y-axis. Okay, let's look at the example here. Okay, this is the last one before I stop. Okay.
Example 1.6, we're going to calculate the x and y components of two vectors as shown in these diagrams. The first vector D has a length of 3.00 meters and is oriented 45 degrees below the positive x-axis. The second vector E lies in a tilted coordinate system, but it itself makes an angle of 37 degrees with respect to the positive y-axis. We identified the equations that are necessary for the solution as being the equations for the x and y components of any vector that has an angle theta with respect to the positive x-axis. And here's the two that we're going to use. Let's begin with vector D. Since the vector lies below the x-axis, this angle alpha is actually minus 45 degrees. If we put that in, we get plus 2.1 meters for the x component, minus 2.1 meters for the y component. Turning to vector E, I note that the angle is respect to the positive y-axis, but we need the angle with respect to the positive x-axis for these equations. So then what we need is theta. It's clear that theta is equal to 90 degrees minus beta, which is going to be 50 degrees. Plugging that into the plus 2.71 meters plus 3.59 meters. Now, if I go back and look at the solutions, first thing I notice that these D have opposite sign, as I expect. It has a positive x component and two arrows pointing down, so it should have a negative y. Furthermore, since it's 45 degrees, the magnitude of these two components should be equal. This vector, however, basically lies in the first quadrant of this coordinate system, and so both its x and y should be positive. Furthermore, the components of this vector should be the three significant figures because but for D, the magnitudes of the three significant figures are two significant figures, and hence the components will only act with two significant figures.
Okay, so that's it for today. All right, any question? Any question? Any question? You guys
No,
still
not
there?
there.
Okay. All right. So let's take the picture for today's attendance. So everyone can turn on their cameras. Come on. Okay. So please smile for your first class of the semester. So hope you enjoy the teaching today. So if you have any suggestion on how I can improve my teaching, so let me know. Okay. So if you want to have more participation, let me know. All right. So maybe we can start it with more questions to be solved later. Okay. So I your participation later. Okay, anyway, thanks for attending today's class. So let's say 1, 2, 3. Okay. Cheers. Okay, thank you. All right. Okay, see you tomorrow. Okay. Assalamualaikum and bye-bye.
Thank you,
Thank you.
Doctor.
See you. Bye.
Thank you, Doctor.
Thank you, Doctor.
Okay, see you. Bye-bye.